Hey everyone, my name is Ehi Edenije. I'm presenting assignment 6, Network and Critical Path for course INDE 6332. My group is Group 4, Elite Engineers, and the team members are myself, Ehi Edenije, Yumyao Liang, Christopher Heisel, Lohit Kumar Reddy, Rohit Roosevelt Sande, and Zohaib Ali. So a brief introduction of our project. So to successfully carry out this network project, our group was tasked with developing a network and critical path. The network and critical path was derived using the work breakdown structure, the WBS, and the time duration from our Gantt charts from assignment 3. The methods used in this assignment involves developing a network and a critical path. Part of the network was using the 3 points of 3-point estimating to find the optimistic estimate, the pessimistic estimate, and the most likely estimate. The optimistic estimate is basically a best case scenario estimate, meaning that if there were no hiccups or problems with the project, the estimated time would be less than the time duration from the Gantt chart. And the pessimistic estimate is basically a worst case scenario estimate, meaning that if all should not go to plan, the estimated time will be more than the time duration from the Gantt chart. And then the most likely estimate is the most probable time a task would take in direct relation with the time duration from the Gantt chart. For the critical path is basically a series of connected activities between two events. A critical path are activities, events, or paths, if delayed, would delay the completion of the project. The critical path can also be the sequence of critical activities and events from start to end, which cannot be delayed without delaying the project. With the critical path, the nodes have 4 different entities. One, the earliest start, the earliest finish, the latest start, and then the latest finish. The earliest start is the earliest time an activity can commence. The earliest finish is the earliest time an activity can be completed. And then the latest start is the latest time an activity can be started without delaying completion of the project. And then the latest finish is the latest time an activity can be finished without delaying the completion of the project. To find the time expected and then the variance, we had to use some formulas provided in the course. To find the time estimated value, it's the optimistic plus 4 times likely plus the pessimistic value divided by 6. And then to find the variance is the pessimistic time value plus the optimistic time value divided by 6 raised to the power 2. As you can see from this figure, figure 1, task with time estimate, you can see we have a WBS structure right here, which is basically the very far left column, the 1, 1.1, 1.2, 1.3, and then that corresponds with the tasks. So for example, for the WBS1, which is the hall, for 1.1, we have the specified components for the hall. For 1.2, we have the order the components for the hall. For 1.3, we have the receive components for the hall. And then for 1.4, we have to construct the hall. And then the next column is basically the precedence or the predecessor column. As you, for example, for 1.1, there's no predecessors. For 1.2, the predecessor is completion of 1.1, and then for example, for 2.5, the predecessor is completion of WBS 2.4. And then another example for task 4.4, which is install components. The predecessors are 3.4, electrical system installation, 3.5, electrical system test, 4.3, receive components. So all of those tasks needs to be completed or started before we can start task 4.4. And then the optimistic column is the time column for the optimistic values, and then the likely times is the next column, and then the pessimistic time is the next column. As you can see right here, the optimistic time for example 1.4 is 8. The most likely time of completion is 10, and then the pessimistic time for completion is 12. And if you can also notice from this table, you can see that the pessimistic time is always higher than the optimistic time and the likely time estimate. So for the results and discussion session, for our network, we had 35 nodes in total, with the start node all the way down to the end node. So let me just trace some examples for nodes here. So if you can see, is start of the project is right here, and it goes down to task 1.1. The 5, let me zoom this in a little bit. The 5.33 is the time expected, and then the 0.11 is the variance. For node 1.2, there's an arrow connecting 1.1 to 1.2 because 1.1 is the predecessor to 1.2. So basically 1.1 has to be started or completed before 1.2 can start. And if I keep following the arrows here, you can see that the predecessor for 1.3 is 1.2, and then the predecessor for 1.4 is 1.3. And if you also notice down here, you can see that the predecessors for 2.1, 3.1, 4.1, 5.1, 6.1, and 7.1 are all involve 1.4. So for example, for node with the task 3.3, you can see that the predecessors for this task is 1.4. You just follow the blue arrow. And then for another predecessor is 3.2. And from that 3.3, that traces all the way down to the ending of the project. And then if you look, for example, for let's see, node activity 6.5. The predecessor is 5.5. See, for example, for node activity 5.3, the predecessors here are 1.4 and 5.2. So this is the network with the critical path. And let's start from 1.1. So the project starts here so that there are no predecessors. That's why the earliest start time is 0. So by the way, the earliest start is 0. The earliest finish is 5.33. The late start is 3.33. And then the late finish is 8.66. So just to make sure that you understand where the earliest start is, the earliest finish is, the late start is, and then the late finish is. So basically, that 0 means that there's no predecessors for 1.1, and then the 5.33 to get the earliest finish, which is 5.33. You add 0 plus the time expected, and then you get the 5.33. And now if we move on to task 1.2, since the predecessor is node task 1.1, the earliest start would be the earliest finish of 1.1. So if you can see right here, the 5.33, which is the earliest finish for 1.1, is the same as the earliest start for 1.2, which is also 5.33. And then to get that 10.5, which is the earliest finish, you add 5.33 to 5.17, and then you get the 10.5. And then it all follows the same way. See, for example, let's see. For example, 3.3, you can see that there are 2 arrows, which is coming from 1.4 and also 3.2. So these are predecessors which has to be completed before starting on activity 3.3. So if you look at 1.4, the earliest finish is 26.33. And then if you look at 3.2, the earliest finish is 36.22. So we pick the latest of the earliest finishes, and that becomes the earliest start for activity 3.3. So the earliest start for activity 3.3 becomes the earliest finish of activity 3.2. And then to get the 47.66, which is basically the earliest finish for activity 3.3, you add 36.33 to the time expected, which is 11.33, then you get 47.66. Let's see, if we move on to 3.4, you can see that the predecessors are 2.5 this arrow right here, and then 2.4. So the latest of the earliest finishes of 2.4 and 2.5 is 68.16. So that becomes the earliest start for 3.4. And then to get the earliest finish for 3.4, you add the 68.16 to 5.33, and then you get 73.49. So the project flows like that until we get to the end. So if you can see right here for 3.3, you basically have an arrow going to the ending of the project. And if you can see right here, the ending of the project, the earliest start is 137.66 days, and then the earliest finish is 137.66 days. So that basically means that it would take at least 137.66 days for the project to be completed. Now, to get the latest finish, so the latest start and then the latest finish, you basically work backwards. So for our project, I worked backwards from the end to 7.5. So I picked the earliest finish, and that became the latest finish for activity 7.5. As you can see right here, the latest finish for activity 7.5 is the same as the earliest finish for the end, which is 137.66 days. And then to get the 128.99, which is the latest start for activity 7.5, you subtract 137.66 from 8.67, and that gives you 128.99. So for our project, the critical time is 137.66 days, and then the critical path, we have 4 different critical paths. So the critical path starts from for the first critical path, it starts from 1.1 through to 1.4, and then from 1.4 to 3.3. And then for the second critical path, it goes from 1.1 through to 2.4, and then from 2.4, it goes down to 7.2. And then for the third critical path, it goes from 1.1 through to 2.5. And then from 2.5, it goes down to 3.4. And then from 3.4, it goes down to 6.4. And then from 6.4, it goes to the end. And then the critical path, the fourth critical path starts from 1.1 through all the way to 3.5. And then from 3.5, it goes down to 7.5. And then from 7.5, it goes down to the end. Here are my references for the project. And then I have an Appendix A, which is the WBS and the Gantt chart at the very end of my report. And that's the end of my presentation. Thank you.